Hello everyone, today I will be teaching you guys how to wire your electrical systems, your FRC electrical systems using Onshape. So as you guys can see here, I just have some CAD wire and then I have a simple 10 gauge power wire here. And these wires here were made using the method that I will be teaching you guys about today. So first, what you're going to want to do is just create a new part studio here and enter that part studio. And first off, you're going to want this feature script, which is just called wiring, not this one. You want this one right here. And I will link it in the description so you guys can get that. Next, once you have that, you're going to want to search for routing curve, which is built in. Onshape provides you with it. And as you can see, it's a pretty complex menu here. Just make sure you have interpolated spline selected, and you really only have to focus on this points section here. So as you can see, our reference point is automatically set to the origin, but you can change this to vertex, curve, or relative. So what we're going to do is we're just going to click add point here. So something to note is when you add a point, it gets placed in the spot or the same coordinates as your last point. So let's drag this point here, and keep in mind our first point is still at the origin, and now our second point is just going to be like, let's just say I just want to keep it here. And another cool thing about this is you can drag this point in any of the three axes, so the Z, Y, and X axis. So I'm just going to click add point again. As you can see, the coordinates are the same as the last point. So this is still a straight line here, which isn't really what your wire is probably going to look like in a realistic situation. But as soon as we add this third point here and we start dragging it, as you can see, this starts to curve like a wire would in its natural state. So I'm just going to add a couple of points here just to mimic some like basic wire shape. So I'm just going to drag it like that, maybe go up a little bit, and I think that is good. I'm going to hide these planes just to make it easier to see. So we have this basic wire shape here, and now what we're going to do is we're going to use that wiring tool, that feature script, and you're going to want to select curves. And this wire path selection, you just want to click on your routing curve here and click that check mark. So now as you can see, we have this very basic wire sort of shape. It looks like a noodle almost. Now what we're going to talk about next is setting your wire sizes. So as you can see, this tool automatically set my wire diameter to 1/8 of an inch. Now let's just say, I don't know, maybe I want to use a 10 gauge wire. So like a standard 10 gauge wire size, including the insulation, is like around 0.17 inches. But I don't want to memorize that decimal, and that's just 10 gauge. What if my system includes multiple different gauges? I don't want to have to memorize all those decimals. So we're going to make use of the Onshape variable table. So what I'm going to say here, I'm just going to create a variable 10 AWG, so 10 gauge. We're going to set its value to 0.17 inches here. We're going to close out of the variable table, and we're going to edit our wiring tool here. And we're just going to say 10 gauge. Hold up. Forgot. You always want your variables defined at the start, of course. We're just going to name this 10, or we're going to set it to 10 gauge. So if I click the check, of course, it was already at 0.17 inches, but this is just a little tip just to make it less annoying when you're CADing these wires. So now that we know how to make a basic wire here, and of course you can like set the material, so I don't know, maybe I'm just gonna say it's copper, right? And then I can set the color to, you know, whatever, like let's just say red, and we just have this basic 10 gauge wire, which would usually be a power wire for some sort of motor. So now let's get into some practical examples here. So I have this basic test board set up here, which is taking a second to load here. 1 second. Okay, there we go. Sorry about that. Okay, so we have this basic test board here. Just have a main breaker, a battery, a PDH, a Rio, and this motor here. And so what we're gonna do is we're just gonna wire the battery to the main breaker, and then we're just gonna create a simple connection between this Kraken motor here and the PDH. So first off, what we're gonna do is we're gonna take our routing curve tool, and 1 second, actually first off what you're gonna do is you're gonna create a part studio in context. Forgot that we are in an assembly right now. So we're just going to select our origin here, and make sure you create a part studio in context, because it just makes it infinitely easier to do your wiring. So now we're going to select our routing curve tool here, and for the reference this time we're not going to select the origin. I'm just going to select a vertex here, and I'm just going to I don't know, click on this vertex right here. And let me get a better view here. I'm going to zoom in. And now my reference is the vertex, so I'm just going to drag this point, since I don't want my wire to start at the corner there. I want it to start more centralized. Just going to drag our point just like that. Yeah. And then we're just going to add another point here. So if you do want to be fancy, I guess you could say, you could add your connectors, your wire connectors, but I just believe it's unnecessary. It's a waste of time, because I guess you can make the argument it adds to your weight, and let's say you're doing it for your robot, maybe then you want to do it, but again, it's not really necessary. So we have the second point here. We're just going to drag it up, and we're going to actually push this a little bit towards the negative on the y-axis. And we're going to add another point here. And we're just going to leave that one right about here. And add another point here. Just going to drag this down. And I'm just going to put this anywhere. Again, it's just an example. So, just like that. And now we're going to take our wiring tool here, our feature script. We're going to click curves, and we're going to select this right here. Now, I don't have 4-gauge wire off the top of my head, so I'm just gonna say 0.35 inches. Again, I don't remember. This looks about right. So as we can see here, this is kind of way off, this wire here, so we can actually edit our routing curve. And I actually messed up with this point here. You always want to be careful where your point is, because your perspective will matter a lot. It might look like it's in the right spot, but it's probably not. So we're going to click on this point, and actually we're going to add another point right here, just so that we can straighten out this path of the wire. We're going to select this one. And we're probably going to want to drag this up. And then just going to center that. It's basically centered. Click the check mark here. And then we're going to edit. And as you guys can see here, this is a common error that you might run into, and it's usually only with higher diameters. If I set this to 0.1 inches, our error goes away, and this error that we're dealing with is the sweep intersecting itself, the path. So basically, why does this happen? Well, it's because you had too many sharp turns, or you had a sharp turn basically. Just one sharp turn can cause this. So how do you fix this? Well, I guess you kind of just drag your points slightly more. So I guess I can drag that one there and drag it down a little bit, and we can just test. Wait, I clicked the X there. Oops. I'm gonna drag that to the side and drag it down a little bit. Click the check. And as you can see now, it works because I guess that point was my error spot there. That was where the sweep was intersecting itself. So if we zoom in here, you can see this is of course not aligned well at all. And like I said earlier, you can use like wire connectors if you want, but it's really not needed when it comes to wiring on CAD. You don't have to get that precise. You just need your basic layout. It's really just like mapping out where you want your wires. Alright, so now we're gonna look at connecting our motor to the PDH here. So let's just say I want this motor in port 10. So we're gonna open up our routing curve tool here. We're gonna select vertex, and let's get a better angle here. I'm gonna zoom in, and I can just click anywhere, just wherever there's a vertex. So let's just say like right there. And again, we're gonna get a better view here, and I'm just gonna center our starting point here, just like that. And I recommend, if you are gonna put your wires into some ports in your CAD, push the wire slightly back into the port. Now we're gonna add a point, and now we're just gonna drag this one out, and we're gonna also drag it slightly up, just like that. Okay, so now we're gonna add another point here, and we're just gonna kind of drag this towards our motor. So this is gonna go into this port right here. So I'm just gonna drag this just like this, up a little bit, get a better view here. One second. At a kind of interesting angle because this motor is kind of just floating here, but that is all right. And we're probably going to change this. As you saw when we were wiring the battery, we had that sweep intersection error. We don't want that to happen again, so yeah. And then I'm just gonna change this point slightly just to line it up a bit better. And of course, on these motors you would have those connectors that you would screw in. Again, they're optional. You don't need to have them. I'm not gonna do them just because this video is just pure wiring. So if you want to add connectors, I'm sure you can find them in some public document, and I mean, you can just make them. They're very basic, should not take you more than a couple of minutes to make one. So I'm going to click on the wiring tool here, and we're going to select curves. I'm just going to select this right here, and I don't have the variable in this part studio, and I'm just going to select 0.17. I don't need to make the variable since it's just a single wire. But again, if you're doing multiple wires, a complex, wiring, you're wiring some sort of complex system, then you definitely want to make use of the variable table. So now we just have this basic wire connection to the PDH, and then the red power wire would be, it's pretty self-explanatory, we kind of just follow the path. And I think that's basically the basics of wiring these power wires. So now what we're going to do is we're going to enter back into our old part studio, and now let's talk about how we can create this twisted CAN wire right here. So the idea is basically the same. We want to use that routing curve, but there's one little twist that we're going to add to it. So I'm going to select routing curve again. I'm going to start at the origin. I'm just gonna go ahead and I'm just gonna delete this for now, so we don't really need it anymore. I'm gonna select the origin here, and we're just gonna create a very basic wire path here, just like 4 points. Just gonna add another one like that, and there we go. So we just have this basic routing curve, and now here is where the second feature script comes into play. So I will also have this one linked in the description, and that feature script is going to be the 3D spiral. So this tool right here, and again, it should be in the description. So this tool, compared to the routing curve, much more simpler. As you can see, we just have the spline edge selection, so we're just going to select our routing curve here. As you can see, it kind of generates this crazy shape, and that's because the radius. So setting your spiral radius, I recommend just keep it the same as whatever gauge wire you're dealing with. So in this case, we're with CAD wire here, so I'm just going to set the radius to like 0.075. And now the number of revolutions. So how many times it will twist along this. So I'm just going to set this to 10. That looks pretty good. And we're just going to click check. So as you can see, we have this one spiral right here. And what we're going to do is we're going to open up the 3D spiral one more time. And we're going to select that same routing curve. We're going to set the radius slightly smaller than the previous one. And you'll see why. Number of revolutions, the same. And this time we're going to flip spiral direction. And you're going to want to click check. So as you can see, we have this spiral shape around our routing curve. Now what we can just do is select our wiring tool here, curves, and you can only select one at a time, because if you select two, you will get the sweep paths are not all connected error. So just select one, and for our wire diameter, we're just going to set it to like a basic CAD wire size here, and we're going to click check on that. So we're going to open up the wiring tool one more time, and we're going to select the other spiral here, and again we're going to set that to a standard CAD wire size. So let's let this load here, and as you can see, we have this basic sort of DNA spiral, or what CAD wire would look like when it's twisted. So of course there's little tweaks you can do here and there. So if let's go ahead and edit this 3D spiral. I don't know, maybe I want to put, maybe I want the radius to be smaller here. I know I said keep it the same as your wire gauge, but that usually will work only if you have longer wire lengths. In this example here, I have a pretty short wire here. It's 5.26 inches. So we're going to reduce our radius, probably even slightly more, maybe like 0.0425 inches here. I'm going to keep the number of revolutions the same. When you're dealing with CAD wire, you at least want 1 twist per inch. Here we have 10 twists over 5.2 inches, so it's perfect. Like, we could set this to 5 if we want to, and that would be totally fine, but I'm just going to set it to something like 7. We're just going to click check here. Then we're going to wait for this to load, and we're going to edit our other 3D spiral. I'm going to set the radius to like the same, and for the number of revolutions, as you can see, it kind of looks like interesting. Like, it'll intersect in some spots. So what you can actually do to fix that is just fluctuate the revolutions by 1 or 2. It depends on how much you have, again, how long your wire is. So I'm just going to set that to 8. Now if we click check here, as you can see, it does intersect in some spots, and that's what I mean. Like, if you want it to look really good, you can keep tweaking these, but it ultimately does not matter that much. Like, if your CAD wires intersecting each other, in the CAD, that's not really a big deal at all. So I don't know, maybe I'll set this to maybe 6. Maybe I'll set it to 6. And yeah, I mean, it's really just a guessing game. I mean, I guess you could do the math and find the perfect answer, but it's really not worth it. So basically, what we're going to get into next is what I think is probably the method that everyone should be using when they're wiring, and that is what I call grouping. So it sounds very basic, and it actually is very basic. So as you guys can see here, I have this CAN wire here twisted, and although this may look nice when you fully wire your bot on the CAD, it's a major waste of time. Instead, what you should be doing is just grouping your CAN wires. So I'm just going to create a very simple run here. Only 3 points. Wait. Messed that up a little bit. Just like that. And we're going to use our wiring tool once again. I'm going to select that, and instead of 0.07, we're just going to select like 0.12. So slightly bigger than a CAN wire size. But instead of using 2 wires, this just represents my twisted CAN, my CAN high and my CAN low, the yellow and green respectively. And so this will save much more time when you're routing, because you don't need to, double down and create twice as many wires, and you definitely should not be doing all this twisting stuff. I taught it to you because it can be cool, and if you do have the time, then it's definitely worth it. I mean, your CAD will look clean, but if you want to focus more on actually testing your robot or whatever system you're making, then it's much better to just use basic wire designs that just get the job done and get your layout. So you can actually apply this same method to power wires. So let's just say, I don't know, wait, I'm just going to edit this wiring here, and we're just going to say like 0. This one we're going to actually double the value, 0.3, because you don't twist your 10 gauge power wires usually. And if this was, let's say, like an 18, like 22 gauge power wire, then yeah, of course you can twist that, and you don't have to double your wire diameter. But just for this, since you don't want to twist your 10 gauge wire, we're just going to keep it at 0.3. So yeah, you never really want to go too complex unless you have the time. And let's just talk about this here in this drivetrain assembly. I have a very basic drivetrain set up here, and I'm not really gonna show any wiring being done on this, since I do think most of you guys probably get the idea. You don't really need to know how to do this immediately. It's really just practice, but you're really only using 2 tools most of the time. So if you want to be very efficient with your wiring here, you only want to actually demonstrate the major connections. So what I mean by major connections is, I don't know, maybe I want to wire the CAN between this motor here and this motor here, because I'm using the daisy chain method. Or wiring the power. You definitely always want to wire the power to all your motors and all your systems. But for the CAN, you don't necessarily need to always do that. So a good example is if you have swerve modules. So this drivetrain here is using SDS swerve modules. There's no point in me wiring the CAN between these 2 motors, or really wiring the CAN between this CAN coder and this motor, unless this CAN coder is going somewhere else. So I don't know, maybe on this bot I start off at the Rio and I go straight to the CAN coder. Okay, maybe I do want to wire that, because there could be some other subsystem that could potentially affect the routing of that. But if it's just between these 2 motors here on a swerve module, there's most likely never going to be any system that will somehow be able to disrupt the connection between these 2. If there is, then your system is probably awkwardly placed or overly complex, because as you can see, the distance is very small. But basically the point is you only want to wire major connections that you know could be affected by subsystems or other, electrical components, whatever, whether that's the battery or like a VRM or whatever it is, your PDH. It doesn't really matter. Anything that can affect that your wire's routing, you always want to route that connection. But if there's some minor connections, such as between these two motors here, it's a waste of time. So here's how I would go about wiring this. I would just take a 0.3 diameter and go from here and simply just connect it somewhere in this gap here. Again, you can use connectors if you want, but it's unnecessary. And that would just be for the power, so I would do that for all 8 motors on this drivetrain here. For the CAN, I would just take about a 0.12 inch diameter sweep, and I would just go across like that, and go across, and then terminate wherever at this PDH, and then of course start at the Rio. And you probably want to wire your starting connections and ending connections, or your termination connections, just because those are important and you should always know where those are. But yeah, that's basically the main idea when it comes to wiring. You just want to be efficient as possible, and the number one thing to note is that when you're wiring your bot or whatever system, you're usually just putting a layout out there so that when you're actually doing the wiring in person, or whoever is doing it, you're not guessing, they're not guessing, because you never want to be guessing when you're wiring. You always want to have that layout in your head, because it makes it easier to know what could have gone wrong in the event that something does go wrong, whether you're in a competition or whatever. So just keep those in mind, and it's pretty basic wiring in general. If you can understand the concepts in this video and just know that you should always be mapping out your electronics, then it will be pretty difficult to run into an electrical failure during seasons. Of course, maybe you might have a loose connection here and there, and sometimes there isn't too much you can do about it, but as long as you're able to fix it quickly, then that is what matters. Having messy electrical layouts is never the answer to anything. That's why you always want to be CADing your electronics and always be thinking about it while the actual bot is being CADed. So thank you guys for watching, and I hope you guys learn how to wire using Onshape.